The diagram shown here is the spectrum of the electromagnetic wave. You can see this range is called the RF range or radio frequency range, and this particular range is most of the time used for communication systems, different type of communication systems. This is the microwave range, this is the millimeter wave range, and if you go to the higher frequency ranges, these are the cosmic rays, this is the gamma rays, this is the X rays. So it is showing all the spectrum of electromagnetic wave. If you can see a small range of frequency shown right here, this is the visible range of frequency starting from red to violet, that is 0.7 micrometer to 0.4 micrometer, right? And even smaller range, this one, this range is actually used for optical fiber communication system ranging from 1.7 micrometer to 0.8 micrometer. So basically whatever you are seeing, that starting from the lowest possible frequency to highest possible frequency, only this very tiny range of frequency is actually useful for optical communication system, and we are using even smaller part of it, not all the portion of this range. A smaller part of this whole range is actually used in practice. Now let us try to understand the basic block diagram of optical communication system. So before that, let us recall the block diagram of conventional communication system. Here we have the information source, that is information generator, or the thing that generates the actual information. Next we have the transmitter, and the transmitter consists of modulator along with some other functionalities like filtering, like power amplification, etc. Next we have a transmission medium, and the transmission medium is used to carry the information from the transmitter to the receiver with minimum amount of error and distortion. Now the receiver consists of several functionalities like filtering, amplification. One of the major job of receiver is the demodulation, then again filtering and amplification of the received signal, recovered signal, and finally we have the destination where actual information is stored. So this is the basic block diagram of any communication system. Now what extra blocks we have to add for optical fiber communication system, right? So basic blocks will be there. Along with the basic blocks, we have to have some other blocks for optical fiber communication system. So information source will be there, right? Next we have electrical transmit, just like this one. We have electrical transmit, but optical fiber will not is not able to carry the electrical signal, right? So we have to convert it to the optical signal, and for that we need optical source. Okay, that is the extra thing. Next we have the optical fiber cable, that is the transmission medium. Next we have optical detector. That optical detector is actually converts the optical signal into equivalent electrical signal. Next we have electrical receiver like this one, and we have the destination. So basically we have to add this part and this section. Two blocks we have to add. One is the optical source and another is the optical detector. In other words, we can say this optical source is nothing but electrical to optical converter, and this one is the optical to electrical converter. So these are the basic block diagram of the this is the basic block diagram of the optical fiber communication system. Now if we consider the digital optical fiber link using the semiconductor laser source, we have to change the system a little bit. So we have the digital information source, and since that information is in digital domain, we can have different type of encoder. Okay, the encoded data will be given to the laser driver circuit, right? So laser driver circuit will change the information source um, according to the uh, which is compatible to the laser. Hmm. And the laser will convert this electrical signal into the equivalent optical signal. That optical signal will be coupled to the fiber, optical fiber cable, and then it will come to the receiver side. In the receiver side, we have avalanche photodetector that will actually the optical to electrical converter, and then the received signal will be amplified and equalized. And after that, we have the decoder because we have used encoder. So we have to use a decoder, and finally we will have a digital output. So when we have a digital optical link, uh, our block diagram will be like this.